Let us start integration by parts, the next topic from indefinite integration. In this method is useful when the integrand is expressed as the product of two different types of functions, one of which can be differentiated and other can be integrated conveniently. We will see the theorem which will states how to integrate the product of the two functions. If u and v are differentiable functions of x, then integration of u v d in dx is equal to u integration of v dx minus integration of, in bracket, du by dx integration of v dx into dx. So basically this theorem tells us that whenever there is a product of two functions u into v, then we will integrate the functions as first function will keep it as it is, then we will integrate the second function minus integration of, in bracket, the derivative of the first function into integration of the second function. So let us see the proof of this theorem, as it is important from the board's point of view. Let integration of v dx is w. Let us take the integration of v as w. This is our equation number 1. So by using the definition of the integration, the integration is an opposite process of the derivative, we get v is equal to dw by dx, as w is the integration of v, the derivative of w must be equal to v. So this is our equation number 2. Now this is the next important thing we have to keep in mind. We are considering u into w, d by dx of u into w. So there is a product of two functions u and w, and we are differentiating it with respect to x. So u as it is d by dx of w plus w as it is d by dx of u. So this dw by dx is nothing but u from equation 2. So u into v plus w into du by dx. So here we get the derivative of uw is uv plus w du by dx. Barabar? So by definition of the integration, here we are using the definition of the integral again. So if the derivative of this function is this function, so integration of this function must be equal to this function u and w. So uw is equal to integration of uv plus w du by dx into dx. So separate the integral, you get integration of uv dx plus integration of w du by dx. So this u is as it is, and this w, I replaced it by the equation number 1. W is replaced by integration of v dx. So I get u into integration of v dx is equal to integration of uv dx plus integration of du upon dx into w dx. Now in next step, what we will do, we will keep this term to one side and these two terms to other sides. So I get integration of u v dx is u integration of v dx minus integration of du by dx integration of v dx dx. So we can state this theorem as u into v. The first function is u and second function is v. So first function as it is, integration of the second function minus integration, in bracket, derivative of the first function into integration of the second function with respect to x. In short, we can write this as u integration of v dx minus integration of u dash integration v dx with respect to x. For example, let us see this example, integration of x e raised to x dx. Okay, so x first function as it is, integration of the second function minus integration of derivative of the first into integration of the second with respect to x. So derivative of x is 1 and integration of e raised to x is e raised to x. So here you get x e raised to x minus integration of e raised to x dx, and its integral is e raised to x. So the integral of this x into e raised to x, that is the product of two functions, is x e raised to x minus e raised to x plus c. Now let us consider the same example in reverse order. That means we are interchanging the first and second function, the place position of the first and second function. Here the first function is x, and we will consider the first function as e raised to x. Then what will happen? E raised to x, the first function as it is, integration of the second function minus derivative of the first, integration of the second. So integration of x is x square upon 2, and derivative of e raised to x is e raised to x. So e raised to x into x square by 2. So we got the integral e raised to x into x square dx. Okay. So initially from where we have started, the power of x is 1. Now we reach to the power of x as 2. If it goes on continuing in this way, the power of x will be increasing. It will goes on increasing gradually in each step of the integral. So it is very this type of integral will not help to find the product, evaluate the integral of the given function. Okay, so from this we conclude that it is very essential to make the proper choice of the first function and the second function. So now how to choose the first function and second function? Is there any rule? So there is a rule to select the proper choice of the first function. So how to choose the first function? The first function is to be selected by which comes first in this order, LIATE. In some books it is also stated as ILATE. It doesn't matter. ILATE or LIATE. Okay. Now what is mean by LIATE? Is there any shortcut or is there a notation? It is a notation. This L stands for logarithmic function. If your integrand contains logarithmic function, then we must take this function as the first function. Now second is inverse trigonometric function. The third one is algebraic function. The next one is a trigonometric function. And the last one is exponential function. So whatever functions you have in your integrand, of which you have to find the integral, the first function is from these categories. So first function must be logarithm. If logarithm function is not present in the integrand, the first function must be in inverse trigonometry. Okay, if these two functions are absent, then we must think of algebraic function. Okay, and then the remaining function will be a trigonometric function or exponential function. Just like here is the x is the algebraic function, and e raised to x is the exponential function. So exponential function is the last function. So here is the proper choice of the first function and the second function. So the process ends somewhere. But if here we have not chosen the first function properly, okay, so we are not ending it anywhere. So this is the first function must be chosen by this order only. Let us see this example, integration of sin x into x dx. Okay, so in this function, let us see the rule. What is the rule? It is L I A T E. Is your function contains logarithmic? No. Is your function contains inverse trigonometry? No. Is your function contains algebraic function? Then so the next is algebraic function. So here is one algebraic function. So we have to choose this function as our first function. So let us choose it as first function. So first function as it is, then integration of the second function minus integration Then what we have to do? We have to take the derivative of the first function into integration of the second function with respect to x. So d by dx of x is 1 and integration of sine x is minus cos x. So integration of sine x is minus cos x, d by dx is 1, integration of sine x is minus cos x. Simplify, you will get integration of cos x. Now what is the derivative of cos x? Minus 1. So integration of cos x is plus sin x. So the integral of this sin x into x dx is minus x cos x plus sin x plus c. Now let us see some of the solved examples based on this by parts. X into tan inverse of x dx. Here the given function is not in the LIATE rule. So we must think of what is LIATE rule. LIATE. Logarithm function? No. Inverse trigonometry function? Yes. So we must choose tan inverse of x as the first function. So take that is the first function, integration of the second minus integration of dy dx of the first function into integration of the second function. So tan inverse of x as it is, integration of x is x square upon 2 minus integration of dy dx of tan inverse of x is 1 upon 1 plus x square, and this integration of x is x square upon 2. So 1 upon 2 tan x square 1 upon 2 x square into tan inverse of x minus 1 upon 2 integration of x square upon 1 plus x square dx. Now in this step we will add 1 and subtract 1 in the numerator. So we are adjusting the denominator in the numerator, 1 plus x square 1 plus x square. Now we will separate, divide it. We will get 1 plus x square upon 1 plus x square minus 1 upon 1 plus x square. So these two will cancel to each other and you will get 1. So 1 upon 2 x square tan inverse of x minus 1 upon 2 into integration of 1 minus integration of this 1 upon 1 plus x square. So the integration of 1 is x and integration of 1 upon 1 plus x square is tan inverse of x plus c. So the integration of this given function x into tan inverse of x dx is 1 upon 2 x square tan inverse of x minus 1 upon 2 x plus 1 upon 2 tan inverse of x plus c. Now look at this example, x square into 5 raised to x dx. X square is the algebraic function and 5 raised to x is the exponential function. Now exponential function must be at the last. So x square into 5 raised to x. It is in proper order. First function as it is, integration of the second function minus derivative of the first function into integration of the second function. So derivative of the first is 2x and integration of this 5 raised to x is 5 raised to x upon log 5. Now here you will get 1 upon log 5 into x square 5 raised to x minus 2 upon log 5 integration of x into 5 raised to x dx. So this x into 5 raised to x dx, again we have to use the by parts for this only. So in curly bracket, the first function, algebraic function, will keep it as it is, x integration of the 5 raised to x minus integration of dy dx of the x into the integration of 5 raised to x. So d by dx of x is 1 and integration of 5 raised to x is 5 raised to x upon log of 5. So what is the next step? We have to find the integral of 5 raised to x and its integral is 5 raised to x upon log of 5. So simplify it, you will get 1 upon log of 5 x square 5 raised to x minus 2 upon log of 5 bracket square into x into 5 raised to x plus 2 upon log of 5 it's a cube into 5 raised to x plus c. This is the integral of the given function, or you may take 5 raised to x upon log of 5 common from each of these step. Now the next example is x upon 1 minus sin x dx. How to solve this example? So multiply divide by 1 plus sin x, that is conjugate of the denominator. You will get x into 1 plus sin x upon 1 minus sin square x, but it is nothing but cos square x. So if we divide this 1 cos square x by this cos square x to this 1 plus sin x, you will get 1 upon cos square x plus sin x upon cos square. But 1 upon cos square x is nothing but sec square x, and sin x upon cos square x is nothing but sec x into tan x. So integral of x into sec square x plus sec x into tan x. So multiplied the bracket by x, you will get two integrals. Okay, the first integral can be evaluated by using by parts. The first algebraic as it is LIA then t, so algebraic first and then trigonometric. So x as it is integration of the sec square x dx minus d by dx of x into integration of sec square x dx plus in next second integral also the algebraic function will keep it as it is, and then integration of the sec x into tan x minus integration of the first one x integration of the second d by dx of the x into integration of sec x into tan x dx. So the integration of sec square x is tan x, d by dx of x is 1, sec square x integration is tan x plus x into sec x, because the derivative of sec x is sec x into tan x, so integral of sec x into tan x is sec x. So this is the integral of the given function x in bracket sec x plus tan x minus log of sec x minus log of sec x plus tan x plus c. Now look at this example, e raised to 2x sine 3x dx. Now I already told you uh, for this type of function e raised to ax plus b into sine cx plus d for this type of function, and e raised to ax into cos of bx plus c for this type of function. We can choose any function as the first function. There is no need to choose the first function and the second function by using that LIET rule. These are the exceptional cases: e raised to ax sine bx plus c and e raised to ax cos bx plus c. So okay, let us choose the e raised to 2x as the first function, sine 3x as the second function. So first function as it is integration of the second minus d by dx of the first function, then integration of the second function. So sine 3x, its integral is given by minus cos 3x upon 3, and derivative of e raised to 2x is 2 e raised to 2x, and integration of sine 3x is minus sine 3x upon 3. So minus 1 upon 3 e raised to 2x cos 3x plus 2 upon 3 integration of e raised to 2x cos 3x. So in next step, this keep as it is, the first term as it is, then 2 by 3 as it is, integration of this e raised to 2x into cos of 3x. So again we will use the by parts for this. If you use by parts for this e raised to 2x is as it is, integration of cos 3x dx minus integration of derivative of the first function integration of the second function. So if you find the integral of this function, you get 4 by 9 into e raised to 2x sine 3x, but it is actually your given integral I. So 4 upon 9 into, you are getting again I. So from this step, no need to again integrate. So I will put this integral as I. So this minus 4 by 9 will come to this side and you will get plus 4 by 9. Now minus 1 upon 3 e raised to 2x cos 3x plus 2 upon 9 e raised to 2x sin 3x plus c. So 9 plus 4 is 13 upon 9. Now both the sides will have 9, so we can cancel the 9. You will get I is equal to e raised to 2x upon 13 in bracket to 2 sin 3x minus 3 cos 3x plus c. Now this is the activity. We have to prove this theorem. This is the general step. Your e raised to ax into sine bx plus c. Its integral is given by e raised to ax upon a square plus b square into a sine bx plus c plus b cos bx plus c plus c. Similarly, this is the integral of the e raised to ax cos bx plus c. We have to prove it by using by parts. This is activity for you. Now look at this example. Log of log x plus 1 upon log of x bracket square. Now here uh, we will take this first integral I1 log of log x into 1. I am keeping this composite function as it is instead of substitution method. Okay, instead of substitution method I am using the direct by parts. Logarithm function will be as it is, first function, and the second function is 1. So first function as it is, integration of the second minus integration of the second dy dx of the first one. So this 1 dx is integral is x, and derivative of log x is 1 upon log x into 1 upon x. So this x will be cancelled and you will get 1 upon log of x. So I can write it as log of x raised to minus 1 again into 1. So again u into v. I have to use the by parts one more time. First function as it is, integration of the second minus integration of in bracket integration of the first function into dy dx of the second function. Okay, so log of x raised to minus 1 into x minus integration of 1 dx is its integral is x, and dy dx of log of x raised to minus 1 is log of x raised to minus 2 into minus 1 into 1 upon x is the derivative of the given function. So after simplifying, you will get log of x raised to minus 1 into x plus integration of 1 upon log of x square dx. This is our I1. Now we will put this I1 in our original integral. I is equal to log of log x into x minus log of x raised to minus 1 into x minus integration of 1 upon log of x bracket square dx plus c plus integration of 1 upon log of x bracket square dx. So these two terms will cancel to each other and you will get x log of log x minus x upon log of x plus c as the integral of the given function. Okay, now we will stop here.